So in your formula for circle, you have parentheses here that show you a piece of the x and the y for the center. And when you pull information out of these parentheses, in order to find this value of h, you really set that parentheses equal to 0 and solve. And you do the same thing for the y, equal to equation for the parentheses. You set it equal to 0 and solve, which is how they came up with this HK point. So in that particular case, it's real easy to do that. It's not a big complicated thing. And then, of course, your radius, we all know radius is how far it is from the center of the circle to the outside edge. And so, therefore, that's the only two things that are important about a center, because if you know where the center is, you put your compass down on it. If you open it up, your compass to the radius measurement, then when you draw the circle, it'll have that radius. Well, in these equations, we want to look at it from the perspective of these parentheses are important. Now, I probably won't do this on every one of them. I just want to focus on this one. So if you think this in your head, if you think about setting x minus 16 equal to 0, what would you have to do to solve that? Add 16. And that makes it the opposite, right? So couldn't we just make it the opposite? Okay. If I have one that's got addition in it, then what would I have to do to stop it? Subtract it, okay, then that means that would be the opposite also, wouldn't it? So it would be a lot more efficient to just make the numbers in the parentheses the opposite. And that gives you your center. So this center is 16, negative 9. That will save you a little time if you don't go through and do the math, but you just think about what's the opposite of the operation, and that's the sign of the number you're making.
Wouldn't you have to square these two?
No. No. The formula has squares in it. But you do not square them to find the center. You take the information in the parentheses out, you set it equal to 0, and you solve it. And it doesn't have anything to do with squares. The squares only tell you it's a circle or not. And then this number on the end, if we go back and look at the formula, has been squared. So if I want to know what the radius was before somebody squared it, exactly. So you always take the square root of this, and that will be your radius. So it's really simple and easy to pull this information out. It's just a matter of looking at where is the information. So in our next example, there's no parentheses here. So if I set the inside equal to 0, that's pretty easy. There's no inside. It must be 0. Does that make sense? And the opposite of this y is? But when I'm asked to take the square root of 96, I have to tree it because it's not perfect. So I have to find a number that goes into 96 that's on our list. You know, that list of 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, and so on. Which of these numbers on this list probably needs to be an even number? 16 times what? So 16 times 6 makes the final answer to the radius what? That's right, 4 square roots of 6. Now sometimes you'll be fortunate enough they'll give you a graph, and I'm sorry that these graphs are a little fuzzy, because I did my best to make really nice graphs, but when I cut and pasted them over to the smartboard or your worksheet, they got a little fuzzy. But I think you can still count it. So 1, 2, I guess it's 3 over. Does that look 3 over to y'all? And down 1. So 3, negative 1 is our center. How long is the radius? Everybody agree? Well, they're not too bad then if you can count that. They were worse before because they were hand-drawn. I typed this worksheet up because it was awful when it was hand-drawn. All right, so skip to the page that has this on it. I'm going to skip over the independent practice problems and just do the problems that are for the notes. And that way, if somebody finishes their test, then you can work on your independent problems while other people are finishing their tests. We'll see. If there's enough time, I'd like to do both. Depending on how long it takes us to go through just these problems. So use the given information to write the equation in the circle in standard form. Well, I hope they gave me a center and a radius, but unfortunately they don't always do that. Sometimes they give you the radius, sometimes they give you the diameter, sometimes they give you 2 points, and they'll give you the radius at all. So in this one they did. So you make a pattern, and when you make the pattern to just kind of do an outline of it, this is what it would look like. It's a parentheses with X in it and a Y in it, because that's what the general thought process of the standard form looks like. It's supposed to be an adding or subtraction problem in each one based on the numbers. So you're supposed to take these two numbers out and make them the opposite. So what will go with the X if I make it the opposite? Alright, what will go with the Y? And then the radius comes over here and gets squared. And you just put that on the end and you're done. So it's not hard to put the numbers back in because it was easy to pull them out. Everybody agree? But the key is not always are you going to be given everything you need. For example, in our next question, you'll see you have the center and a point. What am I missing? The radius. But we could still go ahead and fill in what we do know before we go find the radius. Because we do know that this center point is what's going to get split and put in these two parentheses. So what's going to go with X? And? Alright. So that part was easy. Now, over here, let's draw a graph. Over 2 up 1 is the center, so I'm going to put a C next to that so I remember which point's the center. And 6, 4 is a point on the edge of the circle. That's what the other point is for. The other point is a point actually on the circle. Too bad it wasn't straight across, because I could have counted the radius. Yep, I can turn this into a right triangle and find the hypotenuse the same way we've been doing it many, many times. So how far is it across the bottom of my triangle? 4. How far is it up? And that's a special one.
5.
There you go. So once we realize that's that 3, 4, 5 pattern, because the hypotenuse is the longest side, we now have the radius without having to do Pythagorean theorem, but we would have had to do Pythagorean theorem if it hadn't been one of our special ones. And that makes this 25. Because 3, 4, 5 is the pattern we memorized the answer to for the Pythagorean triple, just like 5, 12, and 13, 6, 8, and 10, 9, 40, and 41, and many, many others. But that one we're supposed to know. Alright, in our next example, do I have the center?
Yes.
Do I have the radius? No, I don't. But I can get it. Okay. So I can get it by dividing it by 2. That is correct. But I didn't have it, did I? So I have to remember to look for it if I don't have it. And looking for it looks differently for different things. In the last problem, we were supposed to use Pythagorean theorem to find it. This time we just had to half the diameter. So what goes in the first parentheses? Alright, what goes in the second parenthesis? And when we take this radius and square it, it don't look much different, does it? Because 1 squared is 1. But we did square it. So you might want to say 1 squared there somewhere to remind yourself you did square it, in case you just think, because if you went to studying this and you just said, oh, the 1 stayed the same.
We can't wrong for just put 1.
No, but what I'm saying is you, in your notes, if you just wrote the 1 over there, you might have thought you just copied this over there instead of squaring it. That's why I wrote the 1 squared thought. Alright, so I have a picture. Guess it'd be good to know where that center is.
-1
Negative 1, 1. And how long is my radius? Everybody agree? So the final thing we do every time is make them the opposite and square the radius. So if I fill in the first one, I'll have, alright, and when I square the radius, I get 4. How hard is this? Alright, turn to this page. Circle is the easiest one of all of them because all you have to do is fill in. See, all you have to do is fill in and pull out the same way as far as the information. But this is different because this is general form. And when you look at general form, you see nothing. You have no clue what the center is. You have no clue what the radius is. You have no clue where anything goes because not only did they square it all out, with square the first, square the last, double the middle on both parentheses, they moved the number for the radius squared to the other side and made it equal to 0. So somebody's done a lot of work on this problem to make it complicated looking, right? Because I don't see a center, do you? Okay, and I sure don't think the radius was something they squared and got 0. So that's the problem. Somebody has multiplied the entire problem out. They thought that would be a good thing. Not very useful. So we've got to unmultiply. And that's what that completing the square process that I taught y'all the other day was for. We've got to make each one of these problems back into a perfect trinomial with the x's and a perfect trinomial with the y's. And it's called completing the square. And the first thing you do is you reorganize your problem. You see, I have 2 x terms. They might need to be near each other. And for it to be a trinomial, there has to be a third term. Would everybody agree with that? So I need to put a blank there so that I can do that process we learned the other day. Then we'll do the same thing with the y's. We'll group the y's together, and we'll put a blank with it because that blank is going to be filled in with a perfect number here in a few minutes by doing b divided by 2 squared that we learned it on the first packet. And then your constant, because you don't know really if that constant is going to be very helpful for these two, you always move your constant to the other side by adding or subtracting it. So what would I have to do to get my negative 29 over there? Alright, so we're going to add 29 to both sides, and that's going to put my 29 over here. Now this is really important. For every blank that you wrote on the left, you have to put a blank on the right as well, because if you're going to add something to one side, you got to add it to the other side. And because these numbers that are going to go into these blanks are going to make these numbers perfect, we want to keep our equation balanced by doing it to both sides. So now we'll go into that process that we talked about on the first packet. How do we complete the square? How do we get that perfect number? It's b divided by 2 squared. So negative 8 divided by 2 squared. What does that make? You always take the one that's linear, that just has an x. You take that number and divide it by 2 and square it. How much is that? 16? And you put that on both sides in one of the blanks. Then you do the same thing with the y one. 4 divided by 2 quantity squared is 4. Now that's the only one that the number you start with and the other number are alike. So that'd be a good one to memorize. They use it a lot. Now doesn't that look like the process on this side that we did the other day to fill in the blanks? We're just doing it with 2 of them now. Eventually. Then our job is to do the second step we learned on that last packet, which is to take this back to factored form. Remember, factored form is what it is because somebody squared the first, and they squared the last, and they doubled the middle, so we're just going to unsquare it. How do you unsquare something? You square root it. So this will be x minus 4. Why is it going to be minus? 2 negatives make a positive, and 2 negatives add up to negative 8. And so therefore, it's always whatever's in the middle. Now over here, we're going to make a parentheses squared with the y's. So what will that be? Well, square root them. Y plus 2, and it's plus because the middle is plus. And then the other side, you add it all together, which makes 49. So now I can pull my center out and write it up there, and I can change my radius and take the square root and put it over there. Where's my center?
7.
I'll take your 7 in a second. 4, negative 2 for the center, and the radius is 7 because that's the square root of the 49. Okay? Now, for me to be able to graph this and do not a perfect job, but a fairly decent job, I have to realize that 4, negative 2 is going to be down in quadrant 4, so I might need to shift my XY axis just slightly so that I can have a little bit more on that side of the graph and a little less on the other side. Don't put yours yet. Let me see if this is going to work. Sometimes I'll put it in the wrong place and don't have enough. Yeah, that'll work. I got to be able to do what with that 7? What does that 7 represent? So if the radius is how far it is from the center, can't I just count out from the center? So I have to do that in all 4 directions. I have to count 7, 1, 2, 3, 4, 5, 6, 7 this way. 1, 2, 3, 4, 5, 6, 7 this way. 1, 2, 3, 4, 5, 6, 7 this way. 3, 4, 5, 6, 7. Well, I barely got it on there. And then what you do is just do the best job you can to draw a circle. Well, that was really bad there. It might be good if you did a half and a half. It does better if you do a half and a half.
How many squares did you get?
Junior, what's the radius? That's how many I counted. Because that's the whole point of the process, is to start at the center that you plotted and count up 7, left 7, right 7, down 7. Because I can't count diagonal 7. And that's all you do to graph it. Unless you're going to pull a compass out, then you can make a perfect one. Alright, so we need to practice this completing the square process, because that's what's tricky about this whole scenario, is that completing the square process. And I think I have, what? I think there's 3 more of these, and that's will be the end of the notes. That's right. So what that means is I don't need to do anything special on him because he ain't got anybody else to go with him. But I do need to put some special with this y because he has a y term that's not squared. So there's going to be a 3 there. I can't make 3 out of x squared because there's not an x to go with it. But I do need to move this 48 over here. So what's that 48 going to change to? Alright, now when you do this, if you don't put but 1 blank on the left, then you only need 1 blank on the right. And what this tells me is that I know x is 0 already, because I don't need anything else done to that to see that. There's no more information to go with it, so I can't get anything but 0 for that. But I got to get something worked out for this one. So what is 14 divided by 2 quantity squared? So we put 49 in both blanks. Now again, the x is not going to get anything done to it, so there's really no reason to put parentheses around that unless you just like them. But I do have to put something around the y because I got 3 terms that I need to factor into what? Okay, so y plus 7, because the square root of y squared is y, and the square root of 49 is 7, and the plus from the middle. And what's the other side added up to? So now if I pull my information out, see, I knew from the get-go this was going to be 0, but I had to work to get this number. What will my point be?
0.
And then, because this is already squared, we square root 1 and get 1. And so it looks like I didn't do anything, but I really did. Now in this problem, 0, negative 7 is on the y-axis. You've only got to count out 1 on each side from it, but you need a lot of negative to be able to get negative 7 on there. So I would suggest putting your x-axis way up high so that you got the room to come down 7. Because that's what 0, 7 is. 1, 2, 3, 4, 5, 6, 7. 0, 7 is on the y-axis. Excuse me, 0, negative 7 is on the y-axis. It's down 7. And we're just going to count out 1 in all 4 directions from it, so that's not very hard. And it's a lot easier to make a good circle with that one, too. The smaller they are, the better your circle looks. Well, mine's not real good because my board looks like it needs orientating. You can graph it on your own, Junior. You just got to count up 7 from the center. What? Hurry. Alright, so in this one, how many linear terms do I have? How many linear terms? 1. I have an x, 2x. I don't have a y linear term. Does everybody see that? So this time it's going to be the opposite effect of the last one. I'm going to be doing stuff with the x's, but I'm not going to be doing stuff with the y's. Here's another thought. When I look at this number that's in front of that, 2 divided by 2 quantity squared, how much is that? 1. Somebody's already filled it in for me. Did everybody see that?
Don't have to put it with the negative 4.
I don't have to, I can. If the number you need for the blank is already sitting there, don't move it. Because 2 divided by 2 quantity squared is 1. And there's no reason to move that 1 and put it with the negative 4 if that's the number you're already needing. So I've already got my number. I just need to move the 4 over. Because the 4 is on the wrong side, because it doesn't go with the y, because y doesn't have another letter to go with it. So therefore, I kept this number because it was the right one. Now, if you don't recognize that, just move it, and you'll be putting it right back. Won't make any difference. So now, what will this factor into? X plus 1. The y doesn't need anybody because he didn't have anybody to go with him. And again, I could have done this. I could have said the minus 1 over here because I could have moved the 1, right? But then I'd have to have a 1 over here. Would that change anything? Do you see why I didn't move the 1? Not really necessary to move the 1 because that's the number I need. So where is this center? Which is it? Negative 1, 0, because we got to do the opposite. And the square root of 4 is 2. So negative 1, 0 is on the x-axis. Not going to be a really big circle. I probably could just leave the axis right in the middle if I wanted to. Or I can move it over a little bit if I need to. My line's not real straight, but I will. So if I come over to negative 1, 0 and put a dot and plot it, I've got to go out 2 in all directions. I got to go up 2, left 2, down 2, right 2, and make my circle.
Why is the x on negative?
Because the opposite of positive is negative. You always make these the opposite. It can't come out of the parentheses unless you make it the opposite, because what you're supposed to be doing is saying x plus 1 equals 0. Let me take 1 away from both sides. But that's time consuming, so we just make them the opposite, because that's quicker. It's a shortcut. Alright, I want you to try the last one on your own, and we'll check it to see if you got this process right. And I'm going to pause the video while you try number 4. Okay, did you organize your problem as this?
Yeah.
Alright, so there are 3 numbers they use tremendously all the time. The first one I talked about was when it's 4 in the blank, because when the linear is 4, the last one's 4, because if you square 2 and you add 2 plus 2, they're the same thing. Well, here's another thought. When it's 6 divided by 2 quantity squared, they use that one a lot also, because it's 9. because 2 times 6 and 3 squared are the two thoughts behind that, because you double the middle, you get 6, and if you square 3, you get 9. And that's a pattern they use a lot, so after a while, you'll just know that one and not have to do it all the time. And this is the third one. Negative 2 divided by 2 quantity squared is 1, because if you square 1, you get 1, but if you double 1, you get 2. And so those are ones that after a while, you'll just notice they like to keep the numbers small, and they may use them a lot. So what will the first parentheses be? X plus 3 squared. What will the second one be? Y minus 1 squared, correct. And what's the other side add up to? We got a problem. That's not square rootable. So what's my center? And the square root of 6 is the radius.
Why is it why square minus 1?
Because you take the sign from the middle term, because if you square the first and you square the last, they're both positive. Your negatives all went away. The only way you know there's a negative in the problem is it comes from the middle. So that's why you always take your sign from the middle. So now, negative 3, 1, that's a little far over on the left, so I think we might want to shift our y-axis over just a little bit so it's not in the center to have enough room. And we're going to plot negative 3, 1. And then we've got to figure out how in the world we're going to graph the square root of 6. It's not like I can count the square root of 6. Because it's not the square root of 4, which is 2, and it's not the square root of 9, which is 3, right? It's somewhere in between. Oh, so 2 point something?
4.
Okay, so 2.44 is almost 2.5. Would everybody agree with that? So we'll just count 2.5 to be close enough. So we go over 1, 2.5, because that's the best we can do. And up 2.5, and over 2.5, and down 2.5. Because that's the best we can estimate, because our dots are so big, we're already taking up that little extra tenth, right? And then we'll just connect them. So we connect them all up and we get our circle. So you can do it with decimals, but do not write a decimal up there. The square root of 6 is the radius. You can use a decimal to plot it, but you can't do anything else. All right, any questions? All right, so you'll be able to finish all the other problems in the packet by going back. If you forget how to do something, you can look at the notes in the packet.